All right, so now we're going to look at the angles on the unit circle that are multiples of pi over 4. We're going to do this in the same fashion that we created the angles that are multiples of pi over 3 in the last video, okay? So remember, this is going to be our unit circle. All of the angles have to be in standard position, so the vertex will be at the origin. For every single angle, the initial side will coincide with the positive x-axis, so I'm going to go ahead and put that down, okay? And we know that, again, we're going to start with the top half of the circle. The top half of the circle, half a circle has pi radians. Since we are looking at pi over 4 here, we need to take the full pi radians, top half of the circle, and divide it into 4 equal pieces, okay? So that's what I'm going to do here, okay? I'm going to take the top half of the circle and divide it up into 4 equal parts, okay? So just give me a minute to do that. Okay, the second line that I'm drawing in is coinciding with the positive y-axis. Okay, so now I'm going to draw in my third line. So that'll go right here. And then this last line that I'm going to draw in coincides with the negative x-axis. Okay, so here we go. Okay, so the top half of the circle, which is pi radians, I've broken up into 4 equal parts, okay? I'm going to pause the video and color these sectors in, and then I'll resume the video. All right, so I've colored in the different sectors in the top portion of the circle. This kind of helps you visualize that I have broken the top portion of the circle into 4 equal parts. Again, since there are pi radians in the top half of the circle and we've broken the top half of the circle into 4 equal parts, you can kind of think of each of those sectors as representing pi over 4 radians individually, okay? All right, so now you can start labeling your angles here, okay? So again, can't emphasize enough, your angles all have to be in standard position, so each of these angles will have a vertex at the origin. The initial side of the angle will coincide with the positive x-axis, okay? So we want positive angles, we will rotate in a counterclockwise position, okay? So our first angle, we are going to rotate through pi over 4 radians, okay? So this angle right here is going to be pi over 4 radians, okay? So then our next angle, okay? So next time we are going to, again, start with our initial side and we're gonna rotate 1 pi over 4, 2 pi over 4, okay? So this angle right here is going to be, or sorry, oops, let me erase that. This angle right here is going to be twice 2 times pi over 4, okay? So this is going to be 2 pi over 4, which is reduces to pi over 2, okay? And then do it again. Okay, so the next angle, okay, will be 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, so this angle right here will be 3 pi over 4, okay? And then lastly, okay, so here for the top half of the circle, okay, start on your initial side, okay, and rotate. So we're going to have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay, so this angle right here, this straight angle, this is going to be 4 pi over 4, which reduces to pi radians, which we know that is correct. Okay, and so our top half of our circle has given us these 4 angles. Okay, so pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, okay? So we're going to do the same thing because we have to travel the entire circle. So we're going to do the same thing to the bottom half of the circle, okay? We know the bottom half of the circle is half a revolution. It's also going to contain pi radians. So we're going to take the bottom half of the circle and break it into 4 equal parts, okay? So I'm going to pause the video. I'm going to go ahead and break the bottom half of the circle into 4 equal parts and color code, and then I will resume the video. Okay, so I have taken the bottom part of the circle, which contains pi radians. I have broken it into 4 equal pieces, just like I did to the top part of the circle. So that means every sector in the bottom portion of the circle you can think of as pi over 4 radians, okay? So let's continue. We've already looked at our angles of pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. So now we continue, okay? So for our next angle, the vortex will be at the origin. The initial side will coincide with the positive x-axis. We rotate counterclockwise, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 to reach this terminal side. Okay, so this angle measures 5 pi over 4. Okay, do it again. Okay, so next angle, align with your initial side here. So we're going to have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and 6 pi over 4. Okay, so there will be your terminal side. So this angle will measure 6 pi over 4. Okay, this will reduce, both of these numbers are divisible by 2. So 6 pi over 4 reduces to 3 pi over 2. Okay, all right, a couple of more. All right, so go back to your initial side and rotate pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay, so there's your terminal side. This angle will measure 7 pi over 4. Okay, and last one that will have us go completely around the circle one entire time. So here's your initial side. We're going to go pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and this will bring us to the terminal side. This will be 8 pi over 4. Okay. All right, so that reduces to 2 pi. Okay, so there are your angles, okay, that are multiples of pi over 4. Okay, we will go ahead and put the degree measures on here. I forgot at the get-go, I forgot the first angle on here of, your initial side you can think of as the starting point, 0 degrees, which is the same thing as 0 radians. Okay, I forgot to put that on there, so let me put that on there. Remember 0 degrees or 0 radians, that's going to be coterminal with 2 pi, which is the entire circle. Okay, all right, so now let's go back and put the degrees on here. Okay, again, you can start off by looking at that first angle, pi over 4, and converting this radian measure to degrees. Okay, so we know, since we're trying to get radians to cancel, we'll put radians in the denominator and we'll put degrees in the top. Okay, so we know that our conversion factor, 180 degrees, is the same thing as pi radians. Okay, so the radians will cancel. The pi's will also cancel. This is going to give you 180 degrees divided by 4. Okay, that is going to be 45 degrees. Okay, so that tells us that an angle of pi over 4 radians is equivalent to 45 degrees. Okay, so remember, every time you see one of these sectors, you can think of them as representing pi over 4 radians or 45 degrees. Okay, so if you go around the circle and you pick up a sector each time, you're either adding pi over 4 if you're working in radians, or if you're going in degrees, you're going to be adding 45 degrees every time you pick up a sector. Okay, so this first angle that we did measured 45 degrees. Okay, so for the second angle that we did, you would just tack on another 45 degrees. Okay, so pi over 2 is going to be the same thing as 90 degrees. Okay, because 45 plus 45 is 90, and that makes sense because your initial side for this angle is along the positive x-axis and the terminal side is the positive y-axis. That does form a 90-degree angle. Okay, so 3 pi over 4, we would just add another 45 degrees to that. Okay, so this is going to be 135 degrees. Okay, and so then by the time you reach the angle of pi radians, remember you would just add 135 plus 45. That's going to give you 180 degrees like we expect. Okay, and then just keep going. Okay, so 5 pi over 4. Okay, what is that going to be in degrees? Well, you could convert it. You could do a conversion factor, or you can just take your previous degree measure, which is 180, and tack on another 45 degrees to it. Okay, so if you 180 plus 45, that is going to give you 225 degrees. Okay, we will go ahead now and move on to 3 pi over 2. Okay, so take 225 and add 45 degrees to that. Okay, that's going to give you 270. Okay, so this is 270 degrees. All right, couple more. So to move on from 270 degrees over to this next angle, we need to add another 45 degrees, okay? So 270 degrees plus 45 degrees, that's going to give us 315 degrees. And then lastly, okay, we have reached the full circle, which is 2 pi radians. Okay, to get that in degrees, you take your previous measure here, 315, and add another 45 degrees to it. That's going to bring you to, as expected, 360 degrees. Okay, so again, you see that your starting place, 0 degrees, which is 0 radians, that is coterminal with 360 degrees, 2 pi radians. Okay, and so here are your angle measures on the unit circle with your multiples of pi over 4. Okay, so that's going to produce pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then 2 pi. Okay, and then we have the corresponding degree measures as well. Okay, so just to recap how we got these angle measures. Okay, we took the top half of our circle, that's pi radians. We divided it into 4 equal parts. So each of those sectors represented an angle of pi over 4 radians. We did the same thing to the bottom of the circle, okay? And then we started rotating counterclockwise in standard position to produce all of these angles.